we're going to break recursion down into 4 different categories to sort of explain it. And the first one is going to be the stack. How does the computer interact with the code to actually execute recursion? Then we're going to go into the recursive process itself. And then we'll talk about the merge sort algorithm, which is an application of recursion. And then more broadly, talk about divide and conquer, which is really the overarching concept for merge sort and where recursion tends to pop up most frequently. The stack is just the sequence at which the computer executes function calls. And so just to make that point clear, let's do a small example. So let's say we have the following code. And first, main is the first function that we call. And so that means that we have to go inside the main function and we add main to our stack. Then within main, we have our first function call. We're going to go ahead and call that and then add that function call to our stack. So you can see that before we can stop executing main, we have to execute that first function call. So we print out that print statement. Then once that function is complete, we can throw that function off of our stack and move on to the next task, which would be the second function call. And so we execute that function call, we print that print statement, and then we throw that function off our stack. And then now main is complete, and we can throw main off of our function stack. And so that's really it. That's the stack in a nutshell. And I feel like that concept, it really isn't that difficult, but it's crucial for understanding recursion and its details. The quintessential example for recursion is the factorial function. And so to start this, we're going to do the factorial of 3, just to keep it simple. And so we're going to call factorial 3, add that to our stack, and then go through the function. So 3 is not 0, so that first if statement is false. We then go to the else statement, which is n times factorial n minus 1. That factorial n minus 1 is our recursive call. That is recursion, essentially. And so we call that function, we add it to our stack, and we keep doing that until we hit our base case, because we can't really evaluate our function until we know what one of the values are. And so our base case in this instance is when the number is 0. And so we hit 0, and that value is 1. So factorial 0 equals 1. Then we can then backtrack to reevaluate the functions we have on our stack. And so when we go back to do our calculations, we go, okay, the factorial 1 times 1, which is factorial 0, is 1. We do that calculation. And then really what we're doing is evaluating that else statement that has n times factorial n minus 1 that's stored in memory on our stack. And we kind of evaluate those in order. So we go to the next one, which is factorial 2, which is factorial 1 multiplied by 2, and so on. And so what we get at the end is 6, because n, which is 3 at that point, times factorial 2, which we just evaluated as 2, is 6. Now we get to discuss an actual example that people use far more frequently than you think, and that is the merge sort algorithm. And that sort of begins with understanding what would be a base case for sorting an array, for instance. Let's start with an array on the screen. So is that array sorted? And I feel like the obvious answer here is no. But what does an array look like that is sorted but can also serve as a base case? And I feel like the answer is kind of obvious. So what if I only had one element? Is that array sorted? I would say yes, because there's only one element. There's not much you can do there to change the array. And we can use that. So let's take one element as our base case. And so let's go through the process where we take our array and we split it up. So now we have 2 different arrays, and then we do it again. Now we're at our base case. Now we can say, hey, is this sorted? And then what we do is we check, is 3 less than 5? Is our sorted array less than this sorted array? And we can say yes, and then we can position the numbers where they're supposed to be by swapping them. And then we do that for the other set. And then the last set is to branch those things together to make a sorted array. And so here it really is an example of using recursion to divide that array into subproblems that really make it easy to solve, and then merging those things back together. And so that's really the heart of divide and conquer. It turns out that every example in this video is divide and conquer. Even the factorial example, where you break down the calculation to the smallest number possible and then merge all the results. And merge sort is another very classic example. And so really this is a video about divide and conquer, because that's the algorithm that we've implemented the entire time. That's all I've got. Thanks for watching.